So hello everyone and welcome to our 8th iNOG. No, it's our 10th iNOG, right? But because we're geeks, hold on, I have been given a very nice gift, very appropriate for the occasion by our wonderful guests here. Apparently it's for taking to the beach. I will use it as a cape. Hopefully some of this V6 stuff will rub off on me. So, welcome, and I'm so glad that all of you could make it tonight. This is our last iNOG for 2016, and it's been a very nice series of events this year in very interesting locations. And we ended up here at SIG. A few of the guys in the SIG team, they're really great guys, and they've been coming to our meetings for a long time now, and it should have happened sooner or later. So thank you very much for making this happen, guys. As usual, we have a few things. I'll try to be quick. It's probably obvious that we're going to record this and we're going to be taking pictures. If anyone has a problem with that, please get in touch with either myself or Donal. So hello. I should have said, I'm Cristian, I'm one of the organizers. There's Donal, hello. Organizer number 2. So if you have any problems, please get in touch with us, not only about photography, but about anything, or any feedback is usually much appreciated. Please set your phones to silent during talks, and questions are welcome, very welcome at the end. And please state your first name as a minimum when you ask before you ask the question. We have a code of conduct. I will be reading the short version of it. This code of conduct applies to all the interactions with the iNOG community, be it online or in person at our meetings. Basically, we have the full format is on our website on iNOG.net, but very short version is be excellent to each other, which means that our group is dedicated to providing a friendly, safe, and harassment-free experience for everyone, regardless of gender, gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or lack thereof. Thank you. So, by now I think you should know that if you want to get in touch with us outside of the meetings, there's a website, iNOG.net. There's a meetup group we used mostly to organize meetings, and there's a Slack team as well, which is used for more real-time communication or asynchronous communication. We're most of the time on there, so if you want to get in touch with us, that's probably the best way. We have 3 talks today. They are all about IPv6. It wasn't planned, and then it became planned, and then it was made official, right? So it's all good. We have Orla from HEAnet. We have Nathalie visiting us for the 2nd time from the Netherlands and from RIPE. And we have Ed, who will be dialing in from the US, Ed Horley. He's pretty much an IPv6 hero, so we're very happy to have him present as well. As you have seen earlier, we had a few bumps and bruises with WebEx, but we should be fine. Thank you, Cisco. And I think I'm going to shut up now and hand over to Mark, who is our host tonight, and he is going to say a few words to you about SIG and what they do.
There you go. Thanks, Cristian. I suppose welcome the iNOG community to SIG. I'd like to first of all thank Donal and Cristian for giving us the opportunity to host the iNOG. As you mentioned, a lot of the network engineering guys here have spoke very highly about the iNOG and your contribution to the local networking engineering crew here in Dublin and beyond. So I'm not going to keep you too long, but I just want to give people a kind of insight into what SIG do as a company. So essentially SIG is a proprietary trading organization. So we trade on the major securities and derivatives exchanges. So we trade ETFs, commodities, index futures, fixed income, etc., etc. Some of you are probably thinking, what the hell is that? But you know, I won't bore you with the details. But to the forefront of what we do is technology. So, you know, we consider ourselves leading edge and innovative in our use of technology. So we have a team here in Dublin of over 210 technologists at this stage. Everything is built in-house, from our strategies to, you know, engineering our networks, you know, to doing some funky stuff that I'm not allowed to discuss. But, you know, it's a very agile environment, because the way we look at it is that, you know, time to market's crucial, because the traders want to make money. So, you know, if there's an opportunity out there, we have to act fast. So that's kind of how SIG works. It is very, very agile. So how does networking work in SIG? So networking is a very critical component, in that, unlike the main cloud providers where network capacity is probably the main focus, in SIG it's low latency networks is the main focus. I'm not saying capacity isn't important, but low latency is, and availability, especially through trading hours. So we manage 15 co-locations out of Dublin across the US and Europe. So and obviously with that we obviously have a, you know, very how would I put it? So we have a network that has to be highly available, because the European networks, the market data is critical to us. That's what triggers our trades. So in Europe, the exchanges are very fragmented. So unlike in the US, where you have exchanges where you have multiple listings, in Europe that's not the case. So we have 15 trading venues where we may have to do a trade, you know, let's say in Germany, with market data from Milan, for example. So if the network isn't up and down, that'll impact our trading, it'll impact our fill rates, it'll impact our P&L. So low latency networks, high availability of those networks is critical. So we have a 10 gig fiber and wireless WAN that you know, keeps us busy. So I think you would have, from the previous iNOGs, Peter and Tom gave presentations on network automation. So again, that's a key focus for us this year, because as we have 15 colo sites, in those colo sites we have multiple different strategies across the different trading desks, none of which are the same. We actually have different network architectures for a lot of those strategies, and believe it or not, the lifespan of a network architecture for trading strategy is at max 9 months. So we're always re-engineering and re-engineering. So hence the guys in the network team never have a dull moment, you know. But it's good fun, I think. You know, it's, again, I mentioned it, you know, we're looking at leading edge. We sometimes call it bleeding edge, because we predominantly use market data and transport a lot of multicast traffic through our networks. You know, we deal widely with, you know, port replication, tap aggregation, muxing, and things like that. And, you know, so there's all these specific features that are probably not widely used in your general network, but we have to tweak certain features to make things work for trading. So, you know, we use layer 1, layer 2, and layer 3 networking throughout, and it's all different depending on the strategies. You know, we sometimes have switches, we sometimes don't. We sometimes do other stuff that we build in-house ourselves. So it's, you know, it's a challenge, but it's enjoyable at the same time. The unique thing about SIG as well is that all our customers are on site, i.e. the traders. So if we mess up an architecture and implementation, we'll know about it straight away. But more often than not, we like to see that, oh yes, the fruits of our labor, we've done well here. Things are going well, traders are happy. So that's kind of, I suppose, SIG in a nutshell. Another thing we do as well is time distribution is critical to SIG as well. So we have a time precision down to within 100 nanoseconds and getting better. That's critical for us, especially in our back studies. So we record all our market data so we can do R&D. So we have a quantitative research team here who look through all our market data, do analysis and come up with strategies, and then we implement strategies based on their findings and their algorithms. So I think that's probably enough for me. I'll let you kick on with Orla now next. But just to let you know, we are going to go across the road to the Harbour Master for drinks later on. There'll be wristbands given out at the end there just so you can get upstairs, but there'll be drinks and finger food supplied afterwards. Just before I forget, fire exits. So north and south on this floor are the fire exits, and obviously up through the lifts there's an exit, and the toilets are by the lift as well. So the network team and myself will be obviously over in the Harbour Master. We'll be happy to answer any questions you may have, and enjoy the rest of the evening.
Who's the network team? Yeah, there you go. Well represented.
Yes.
So thank you and enjoy the evening. Okay, thanks.
Thank you.
Where's mine? Oh yeah, here we go. So just before we begin, a little bit of a background. Who are HEAnet? I work for HEAnet. We are the Irish National Research and Education Network, or NREN as we're known. And what we do is we provide internet connectivity to all of the universities, institutes of technologies, primary, secondary schools, and anybody that is in any way related to education and research in Ireland that's publicly funded. So it's kind of a broad spattering of all of our clients there, but it gives you an idea of what we do. And we provide them with internet connectivity as the first part, and then services, network services on top of that. So everything from multimedia to edu-roam, storage, all that kind of stuff. So once upon a time, we started working on IPv6, and it's a very long time ago. I haven't given a talk on IPv6 in, I'd say, about 6 or 7 years. So it was kind of strange to be asked to do it again, but I was very glad when Donal and Cristian asked me. And this is just a talk for a change with no mention of IPv6 addresses or scopes or anything like that. So I'm sure that'll be most welcome on a Thursday evening, not to have to go into that detail. But it's a story just of our experience of deploying IPv6, where we've been, and the various villains, so tunnels, 64 tunnels, which I think are gone the way of the dodo, thankfully now. NAT, vendor bugs, and the heroes, the people who helped work through all those problems in the early days to get us to a stage where now it's a much more usable protocol. So, as an internet service provider, which we effectively are for research and education, one of the first things we do is provide a local internet registry in Ireland for our community. And so when we started down the road of IPv6, the first thing we did was apply for 6-bone address space. So the 6-bone project, for people who aren't aware of it, was a specific project set up at the time to get people familiar with IPv6. There was an address range that started with 3 FFE, and everybody who was interested in starting with IPv6 16, 17 years ago got space there and started playing with networking protocols and routing and that kind of thing. We got our allocation in about June 2001, and we hit our first bug or problem pretty much that day straight away when we went to route it, which was a joy, the sign of things to come, I suppose. We discovered that one of our clients had applied for 6-bone space as well, and when they were asked what their AS was, went, oh, we know that, 1213, and filled that in. So when we went to apply for it as AS 1213, we were told, no, you already got yours, you can't have any more. So it took a bit of negotiation to straighten that one out, but Trinity were happy to hand it back and work with us on that one. We very quickly got in touch with RIPE then a few months later, and we got our proper allocation, initially a /35, but RIPE policy was in a constant state of flux at that time, and they decided to change it to a /32 and keep everything on nice bit boundaries for us, which was much easier maths when it came to IPv6 addresses in November that year, October, November that year. So while digging through my archives of IPv6, I managed to find the who is from one of the first presentations I ever gave. So there's the history of it there. October the 8th, 2001, we got our RIPE address space. So you can believe me when I say we're at it a long time. So the first assignment, we didn't hold it against Trinity. They were our first actual real IPv6 Lear assignment. So they got the glass slipper in 2001, November 2001. And David Malone and Mike Nell, who are, I suppose, well known in the community, were working away on IPv6 themselves in the maths and computer science departments. And they applied for their first Lear space and they got it. And while digging through, I discovered when we gave iNEX their first assignment. So iNEX have always, HEAnet was one of the founding members of iNEX, and we've provided them transit all along as part of our cooperation there. And so obviously with their IPv4 transit, we were keen to get them working with IPv6, and Nick was very keen to do that too. So they got their first allocation in 2003. And I found a note on the application form that we sent back to them saying, you know, although you requested a /64, we're giving everyone a /48. So here you go. Their minds were suitably blown at the time of what to do with all of this space. So then in November 2003, we hit upon an interesting time. Brendan Toohey, who some of you might remember, was the department secretary for the Department of Marine and Communications, Marine and Natural Resources at the time, came to the HEAnet conference. And we were talking about IPv6 and espousing this to our clients, and he was asking, what on earth's all this about? And asked for us to send him the case for IPv6 and explain why this was important nationally for Ireland. And Anna Wilson, who also works in HEAnet, wrote what turned out to be a very prophetic email about this, and said that little did she know, I suppose, that while good progress has been made so far, a number of obstacles are preventing the widespread deployment of IPv6, and chief amongst these is inertia. And here we are, 16 years later, I think, still tackling the same problem. What we weren't expecting was for Brendan to decide to send this case for IPv6 off to Vint Cerf and Brian Carpenter, essentially the fathers of the internet, and say, hey, what do you think about this? Our NREN wrote it. So that came as a little bit of a surprise to us when we got back. The shrug, I suppose it's okay. We might have a few quibbles with it, but mostly they agreed with it. So slightly more so. I wasn't expecting it to be sent off that far. But the positive outcome of this at the time was this email and this case for IPv6 led to the establishment of the Irish IPv6 task force within the government. So we worked on that nationally for a few years as well, and we held 2 national summits in 2009 2010, trying to spread education and awareness around IPv6. So around working with IPv6, this was not an easy job in 2001. Our first port of call was to try and find transit, IPv6 transit. This didn't really exist at the time because it was mostly just the academic and research networks that were working away on IPv6. And we got our first peering with StarTap in Chicago so that we could connect into the 6TAP project. And the 6TAP project was a joint effort between the Energy and Space Science, HEAnet, the science network in the US, and Canary, which is the HEAnet equivalent in Canada. And so we had to haul ourselves over to Chicago to get some IPv6 routes, essentially. And we did that via the government STM1 circuits at the time. Later on, a few months later, we got peering with Cello in the Netherlands, who became NTL, who became UPC, so on and so forth, and HEAnet were one of them. And again, while digging in the archives, I found my network diagram from about 2002, looking super simplistic here compared to what we have today. But essentially on the left-hand side there was the IPv6 network, and it joined into the IPv4, the main network, via our 2 Lightstream switches down the bottom there, Amberville and Dactyl. And I highlighted it, but we had a 2 megabits per second circuit from City West to our offices in Bridge. And this was the height of sophistication, I'll have you know, back then. And an equal 2 megabits to Chicago for our IPv6 connectivity. But it more than did the job at the time because, you know, we were mostly just talking to ourselves and a few friends that we knew. So I suppose a landmark day for us was the 17th of May 2005, just over 10 years ago, when we brought up our native IPv6 peering with Global Crossing. And this was the fruit of a lot of work through tendering and public procurement to get native IPv6 transit from a transit provider, a commercial transit provider, and have it be located in Ireland. So this was a huge step for us to get to that. It was a very busy day because at the same time I was troubleshooting a problem with our HEAnet link, which is the link from HEAnet to all of the other European NRENs. A problem we had noted where all of our IPv6 traffic to European NRENs was going via Abilene in New York, and thus taking rather longer than it should have been to get there. So that morning I was very busy. This is the trouble ticket, by the way. I dug through our archives and found this, saying that I was troubleshooting a problem at 9 o'clock with HEAnet, and in the afternoon bringing up BGP peering for IPv6 traffic to Global Crossing. But there's a nice visual of the effect of that here. So the kind of light purple color was our IPv6 traffic in from HEAnet. Before, this is, sorry, I should point out our RIPE TTM box, which we used to have, the test traffic measurement. And it was a good way of kind of estimating changes in the internet at the time. And along the bottom there are the numbers of the different TTM boxes. We were 35 back in the day. It's a project that's since ceased, but it was a noticeable drop in our before and after connectivity when we fixed this routing problem, that it brought our IPv6 round trip times in line exactly with our IPv4 ones. So that was a dramatic improvement in the quality of our IPv6. In just one day, everything clicked into place. And a lot of you here are probably familiar with the 6XS project. It's, I think, how a lot of us cut our teeth on IPv6 in Ireland. And HEAnet has been hosting a POP for 6XS, for which I'm horrified to say I only discovered 14 years, 5 months and 15 days as of today. And, you know, it's been a very successful service for our community. We set up initially with Pim and Jeroen from 6XS. They presented at a RIPE meeting, and we got in touch with them and said, yeah, we're interested in hosting a POP. We want to help spread awareness about IPv6, and this seems like a good way to do it because none of the commercial ISPs in Ireland were anywhere close to offering IPv6 services, and we had a lot of people who were interested in it. And from our point of view as well, we wanted to enable people to connect over IPv6 to our services from when they were at home and over DSL or dial-up at the time, probably. So yeah, I was talking with Anna about this, and she said, oh my God, is that still turned on? I said, yes, these things tend to just keep working away in the background. It's very low effort on our part. But we think that maybe this year, the 15th year, is probably the time to turn it off. But I noticed there's 406 connected tunnels at the moment on that. But if the tunnels remain, right, there's no real impetus for people to go bug their ISPs to get moved on to a proper connectivity. So I think we're going to pull the plug and cause a bit of inertia there. So you've got 7 months warning. Start making phone calls. So just to wrap up, I suppose, it wasn't all network for us with IPv6. A large part of the work that we did was around our services. Now, I'm delighted to say life was a lot more simpler in those days when it came to the services we offered. Nowadays it's all Moodle this and websites and Drupal and all this kind of stuff, and I'd be horrified to think about how to make Moodle work over IPv6. Even though it's only a website, it's a mess. So what we had to concentrate on obviously at the time were things like DNS, web servers, FTP, news. Who here remembers news groups? And email and NTP were the services that we, were concentrating on, making sure they were dual stacked. So first, that was our approach. Everything we did in IPv4, we wanted to replicate exactly in IPv6 and have everything mirrored, and we did that. DNS initially was just zone files, forward and reverse, and that was complicated enough for most people because of the unwieldiness of IPv6 addresses. that took a bit of time to bed into people. But our FTP server, I think probably most people in the room are familiar with ftp.HEAnet.ie. At one stage around 2005, we reckon it was the busiest IPv6 web server in the world. And that was not without its challenges and woes. When we moved it to new hardware, we hit a particularly fun bug where we were serving traffic over IPv4 and IPv6 for Red Hat. We managed to convince them to give us a C name and not just an A record. And we were serving the traffic, and we were hitting a problem where all the IPv6 connections were getting dropped, or the packets were going missing. And we had to get Alan Cox involved in troubleshooting it, so it was a particularly gnarly bug. And essentially what we discovered was the Linux kernel was being clever and handing off the calculation of the checksum to the Ethernet card, which had no idea what IPv6 was and was trying to do an IPv4 checksum header on it, and the whole thing was catastrophic, to say the least. So that was one of the more intense IPv6 bugs that we had to deal with. There's many, many more, but that one seems to lodge in the memory for some reason. And I have just to show here. This is the day that we turned on IPv6 on our DNS Anycast resolvers. So we could see straight away a lot of demand for IPv6 resolution. I think this was 2009, which was late in the day for us, but I believe it coincided with Google switching on a lot of IPv6 services, so we could see straight away a flip over in the traffic. So just to wrap up, is there a happy ending for IPv6? I think in HEAnet we're all suffering quite a bit from burnout about IPv6 at this stage. I think the pressures and the obstacles for getting it going and getting it used and turning off IPv4 are pretty much the same as they were 10 years ago. And I'm not sure really at this stage if there's anything much more an academic and research network can do. But I think it's kind of over to everyone in the audience here that's running an ISP and working in a content provider to help move things towards providing services over IPv6, because that's going to be the way that things change. I mean, there's been a significant change in the last few years and interest again in IPv6 because of Facebook, because of Google pushing that. So we want to support everybody in doing that. So thank you. And any questions? And my iPad didn't die. 2% battery. Great.
We can use that one. Or we can just repeat the question.
Yeah.
Has anyone got any questions? V6, the beginnings in Ireland?
Lorcan.
Hey, my name's Lorcan. How much of your traffic is going over V6 now?
Oh God.
You can
Some.
repeat the question.
Oh, sorry. His question, sorry, was how much of our traffic is going over at V6 now?
Somewhere in the 5-6%.
Yeah, it's low. It's, I think, around 10%. I can't say I sit there looking at our traffic graphs going, come on IPv6, you can do it. But it's low. It's not significant, to be fair. We did track it for a long time. I think we still do.
We still do.
Yeah.
It's not that big a thing.
Yeah, we wish it was, in fairness, but we still do all of, when we're procuring equipment, everything, you know, we're harassing vendors saying, does this support IPv6? Because we expect there to be a day very soon when that will become the predominant one. Although I say that, and I don't know how the tongue isn't permanently lodged in my cheek, because I've been saying that at least since the year 2000. So yeah, I hope. There is no alternative in my opinion, but at least not now. Any other questions? Tom?
Orla, thanks for the presentation. Tom Smith, small ISP, tracking the schemes on IPv6. Well, it's vendor-led trade, but just wondering about the 6X's box. How much traffic is that pushing at the minute?
Oh God, I really should have looked at graphs. I have no idea.
Just wondering, that's all.
I'll see if we have a graph of it.
Yeah, I honestly have no idea. I mean, they're tunnels, so it's small. The only thing I suppose that was interesting from that point of view for 6XS for us was we gave them probably our largest allocation, which was a /40 out, and they carved that up into /48s and 64s for people. So I've no idea, sorry, apologies. It's probably on their website, 6xs.net, if you want to have a look.
Thanks a lot.
No worries.
I got a quick question.
Yes, Donal.
So, are many universities taking you up on V6 allocations themselves and/or any secondary schools? Or
Oh, okay, that's a good question. So, did everyone hear? Is anyone taking us up on it from the universities and the secondary schools? So, I'll go with the first one. The universities, yes. Most of them have had IPv6 enabled to their edge for 10 plus years. Various levels of influence have, and depending on if there was somebody in the university or Institute of Technology that was interested, encouraged their IT department to work on it, okay? So myself and David Malone bounced around a little bit in our research areas, and we set it up in DIT and in NUI Maynooth. Trinity already had it from the early days when Dave was based there. But about 5 years ago, could be wrong on that, 3 or 4 years ago, DCU set it up, and I had been trying to bribe DCU and James Healy as my alma mater for years to let me come in and just do this for them so they could be the first, but or one of the first. But obviously, it's until there's a need, people don't really go for it. But they hosted a conference, and one of the requirements, I can't even remember what the requirement, which conference it was.
Future Internet.
Future Internet in Ireland, I think, and one of the requirements was you must have an IPv6-ified network, so they got part of their network working over IPv6, but it was enough to open the door and get them talking about it and thinking about IPv6 addressing and plans and stuff like that. And I'm delighted to say they didn't turn it off afterwards, which has largely been our experience. Unfortunately, when people did put the effort in, if the person who was responsible left, that was often the sad outcome of it. So it's been a mixed uptake, I would say. We took the position a few years ago just to give everybody IPv6 to the edge, whether they enable it then on their internal LAN interface and out to their campus network is up to them. The schools, I believe, turned it on.
It's on the school's core.
On the school's core, but not to the. No, it is to the edge devices, to the devices too.
Certainly, as far as I'm aware, there's no schools
The,
currently on V6. There might be one or two, but
yeah,
it's certainly not widespread.
the reason why is the schools project is an interesting project in Ireland and in Europe wide. We're one of the few NRENs that do manage the internet for the schools. And we're one of the few of about 3 that have a content filtering system in place, which is a particularly difficult thing to do, but obviously somebody has to think of the children, and it's us, and to quote The Simpsons. And so getting an IPv6 version of that has proved quite tricky. So that's really been the difficulty in rolling it out to all the schools. Obviously, we can't have the great unwashed of the internet hitting the schools without...
innocent minds.
Exactly, yes. So that's kind of the state of play of it, yes.
Quick follow-up question. This traffic that you're seeing, is it end users, or is it someone from the internet accessing like uni websites and stuff like that? So is it published services, or is it end users connecting out?
I would say in our case, it's probably published services. So as I said, FTP is there. We're one of the largest public mirrors for Linux distributions.
Tickets for your Debian mirrors.
Okay, I do not have anything to do with that. I just host the network it runs on, and all that works. But yeah, so I think that's probably where the largest, bulk of the source of our traffic is. A few years ago, I did a project to enable IPv6 multicast on our network, and that was a resounding success, and it's used all the time. That's what I tell myself for all the work and effort that went into it, and it's not just sitting there idle completely. But it was a proof of concept for us. IPv6 multicast is multicast in general, as the SIG guys know, is complicated, but IPv6 multicast is just another layer again of computation. Yes?
Sorry, just
Go for it.
Yeah.
Do quick, yeah.
one last question. Yeah, just a quick one. How do you find, let's say, after, the research, side of deploying IPv6 to, now where it's steady state for it, how much of an extra load, or is there a noticeable load on your operations, or how do you kind of maintain, your security filters for IPv4 and IPv6, and do you use any cool tools to manage that, to keep, obviously, your IPv6 policies in line with your IPv4 policies?
Okay, I'm going to try and shorten that just to repeat it, so is there any tools that we use for maintaining our IPv6 address security in line with our IPv4 one? You'll probably be horrified to know that we still use ACLs and not any kind of stateless firewall or anything like that. That's largely because the capacity, the bandwidth that we're using doesn't make it suitable to have an edge device, so we secure the end host instead. Which I read in an article today, Google seemed to think is a shocking new revelation. I was like, we've been doing that for years. You can't block a 10 gigabit link or whatever with the firewall. So we manage everything. I think it just comes as second nature now. We've been doing it for so long, but if you implement a rule in IPv4, you also do it in IPv6, or you get a slap over the head from me. It's an effective tool for keeping everything consistent. But that's mainly how we do it, and it's worked so far. So yeah. Okay.
So we just another round of applause for
Thank you.
Orla. Awesome. Yeah.
Below Zoom.
Control L.
Oh yeah.
There we go. Okay, does the mic work? Yeah? Okay, great. Thank you. Welcome. Thank you, Cristian and Donal, for having me again. I was here in April and May, and I really enjoyed being here. So we thought it would be a good idea to come back. And now I'm here doing an IPv6 talk. So my name is Nathalie Trenaman. I work for the RIPE NCC as the IPv6 program manager. And today I brought to you a presentation about some research that we did by accident. Sometimes that happens. And some stuff that we see happening in the region. So as the IPv6 program manager at RIPE NC, I go to a lot of conferences. And I always ask people the question, why do you do IPv6? And the questions in the ISP world are quite simple. We're running out of IPv4, we have to. Now for some enterprises it's a little bit different, because some of the enterprises, for example the large enterprise there is actually Swarovski. They are very busy with IPv6 at the moment. For example, because they have a lot of web shops. And with IPv6, and if you have a web shop, there's something interesting, because we see the percentage of users, home users, that has native IPv6, we see that grow. While we see the amount of users that have native IPv4, we see that slowly reducing, thanks to things as DS Lite, for example, translation mechanisms. So people tend to have native IPv6 connections and sometimes tunneled or translated v4 connections. And if you have a website that's only available on IPv4, then that user with the native IPv6 connection has to have some trickery in the middle to access that IPv4 only website. And that trickery sometimes causes that you lose analytics or user experience because the customer is being tunneled. One of the providers in the Netherlands, Access for All, who did IPv6 for a long time, they said their number one complaint at the help desk with regards to IPv6 was actually not in their network, it was about their IPv6 users that could not reach IPv4 only websites through a tunnel or through a translator box or something. There was something not well set up there. So that is why some enterprises, some web shops now start to see the need for IPv6. There's a big bank in the Netherlands that recently put their website on IPv6 exactly for that reason. So that's a bit what's going on. So where do people do IPv6 then? Well, they do that in Ireland as well. In Ireland, the percentage, this is a graph from our colleagues in HEAnet. They run kind of a similar measurement way as Google does. They use Google Ads. So it's a bit broader scope than just the google.com website. And they see at the moment a bit over 9% of users having IPv6 in Ireland. Now, that number has been growing in the last year, and that's mostly thanks to Virgin Liberty Global. Virgin Media, I think it's called, right? Yeah, that's mostly them. Netherlands is lagging behind, unfortunately, despite everything that we tried to do there. But and the UK made a really big jump this year as well with Sky. Yeah, exactly. Okie doke. So that is a bit in Europe. Oh, there are a few countries. Yeah, you can see that on this slide a bit better. So Belgium is still leading the way. You might want to talk to Hans here about that, how that came to play. He might know a little bit more about that. But Greece, for example, made a big jump. And the case of Greece is interesting. There are two big providers in Greece as well, a bit similar as Belgium. They also had an IPv6 task force where they presented their ongoings. And they changed the IPv6 task force to a NOG recently because the two biggest providers did deploy IPv6. I asked these big providers in these countries, for example, Germany, there is Deutsche Telekom, Kabel Deutschland, who run IPv6. I asked these companies, how long does it take for a full IPv6 deployment? And they say it's about 2.5 years on average. So that's quite a long time. And if you ask guys, network guys in the IPv6 training course, what their supply is for IPv4 at the moment, the average answer I get is 1.5 years. So there's a bit of a gap there. And that means some people have to buy IPv4 or they have to speed up their IPv6 rollout a little bit. Ireland there is nicely on the 23rd position, moving up slowly. Slowly but steady, I have to say. Although it has been a little bit slow in the last 2 months. But pretty sure we see some graphs going up again. So how about our members? We've got at RIPE-NC, we've got 14,000 members in 76 countries. Now that's a lot. And in June this year, we did a big member survey amongst all our members and asked them a lot of questions about the RIPE-NCC. And I was able to sneak in there 3 questions about IPv6. And I got some answers there. How are you doing with your IPv6 deployment? And I was quite shocked to see that 24% have no plans for IPv6. Check the box, no plans for IPv6. The rest of them are either finished or in a stage of IPv6 deployment. And that a stage of IPv6 deployment can be quite broad, from looking at the first upstream until, looking into further stages. So we measure this in a way we call IPv6 ripeness. You might have heard about that. Initially we had 4 stars. It's a 4-star rating system for all our members because we can see certain steps. For example, if an LAR, a member of us, gets an IPv6 allocation. Now, I'll show you the percentages in a moment. The second step is if they announce the allocation. The third step is reverse DNS, and the fourth step is a root object. It's all not rocket science, this part. So those are the different stars, and this is a bit the breakdown for the different stars. As you can see, the 24% who has no plans actually matches exactly what we see in ripeness. So those are the guys that don't have an IPv6 allocation yet. Then we see quite a big chunk there with 1 star, which means they have the allocation and then nothing. For a long time we had an IPv6 policy that required you to get an IPv6 allocation before you could get your hands on the last bit of IPv4, your last /22 in IPv4. So there's a little bit of that in there as well. There's people who got their allocation, now maybe are in the planning stage, etc. The 2 stars are the guys that are announcing IPv6, and the rest of my presentation is a bit about the 2-star story. But 2 years ago we decided, okay, 4 stars is not enough. I mean, this is all not rocket science. What counts is if we see actual users on IPv6. So we made a 5th star. That's the 5th star. And at the moment we only measure content providers and access providers, because we can measure these kind of things. The content networks, we look at the Alexa 1 million list, and we look at if they do IPv6 and how high they are ranked on that Alexa list. Then we extract that with a percentage. The access networks, we look at the percentage of IPv6 enabled users from the HEAnet ads measurements that I showed you the graph from recently. Now I asked the community, the RIPE community, okay, this 5th star, I want to basically tickle people to keep the 5th star, and that's why I want to raise the percentage every year. And And this year the percentage is 16%, and the RIPE community said, double that every year. Keep them going. So next year, as of the 1st of January 2017, the percentage will be 32%. Now, at the moment, I did some checks before I got here. At the moment, we've got 4 members in Ireland who have the 5th star. And those are, I have to have a look. I know 3 of them. First one is the .ie registry for a long time. Second one's Virgin Media, of course. We saw that earlier. And then there's a company called DIDWW. You heard of them? No? Me neither. But they have 5th stars, so pretty cool for that. Last one is HEAnet, of course, like Orla said. Now, I knew Brian would be here. And I don't know if he got his 5th star t-shirt, because 5-star LARs qualify for a unique 5-star t-shirt. So I brought one for Brian, but I didn't bring one for Orla, but I'll ship it to you. Okay. Brian, there you go. You got yours. There you go. Well done, guys. Well done. Yeah. Well done. And from the looks of it, you qualify next year as well. So more t-shirts for that. Yeah. If you work for .ie, drop me an email. My email address at the end, or at Virgin Media, drop me an email. Or DIDWW, drop me an email. I'll be happy to send you some t-shirts for the team. Now, that 2nd star I was just mentioning, that was an interesting one, because we did some other R&D research. And one of the R&D guys came up to me and said, Nathalie, we have a problem. We found that in the course of 1 year, 462 LARs stopped announcing IPv6. And I thought, what? That's 10% of our member base that stopped announcing IPv6 at some point. So I wanted to know why, right? I mean, that's a good question. So I sent an email to all of them, all the contacts that I could find, with a tiny mini survey in there with 6 questions on why did you switch off IPv6. I got 69 responses in 2 weeks, and I got a lot of emails. And the emails were mostly from managers saying, excuse me, I thought it was on. Let me get back to you. And some of them did and said it was fixed. Yeah. So immediately I wanted to know, is this a country problem, or is this, where are these people? So I checked where they came from. Ireland is not on there because I didn't put on the slide all the countries. Ireland had 3 of these cases. So there were 3 LARs in Ireland who stopped announcing IPv6. I checked, one is by now a closed LAR, so they stopped paying their bills. So that could be a bankruptcy or something. One's back on by now, and one is still not back on. So that's a bit what we see in general. Now, you see there Great Britain, you see Russia, big spikes there. That is not unusual. That's because we have a huge member base in those countries. So that matches a bit with the percentage of members that we have also in the other countries. So there was no real sign that this was a country thing, I thought at first. So the first question I asked, did you know you were announcing IPv6? And I got some answers back saying, I had no idea. Okay, so maybe I was probably talking to the wrong people then. So probably. So, but a lot of them, they knew they were announcing IPv6, which was good. And then my second question was, what was the purpose of the announcement? And obviously, a lot of them said it was a test before we were going to plan production. But there were quite some guys that were in production when they stopped announcing. So, and again, the same guys that didn't know they were announcing weren't sure why it was announced, of course. So I asked, so what were the problems that you encountered? And a lot of them said no problems, which is good. So it was basically just a test, and that was it. We had some software issues, hardware issues. I'll get to that in a second. Routing issues, some security issues, customer complaints. I didn't ask specifically if the customer complained, what was it about. Should have had, but didn't do that. A lot of the people said it was just a test. because we test every part of our network before throwing things in production. And some guys said, well, we are waiting for the test customer, and they never came back. Some people came to the conclusion that they needed new equipment, because some of the equipment couldn't handle it. Routing tables, I heard that. Some people say, well, we stopped announcing because first we want a proper IP address management solution before we start with the distribution of more IPv6, which actually makes a lot of sense. An IP management tool is not too much of a luxury when you start doing IPv6, because Excel might not really be the best thing.
Works fine.
Works fine? Yeah. Another thing that I came across was people saying, well, our network department was ready, we were ready. And then we got complaints from other parts in the organization saying, no, 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 you can't just do this. You have to talk to manager X or department Y or group Z. IPv6 is not supported in my country. That was an interesting case. There's one country, and because it is being recorded, I shall not name names. But this country had a lot of IPv6 through a tunnel broker. And the tunnel broker stopped, because of sanctions against this country, stopped with the tunnels. So basically the whole country didn't have IPv6 anymore. Now, that is changing, luckily. Now this country is getting native IPv6 finally. But that was basically from one day to the next, we saw that this country was not having IPv6.
Sorry.
Yeah.
Does that mean that no provider in that country
Exactly.
wanted to implement V6?
They couldn't. They couldn't, because this country had only one upstream provider. That was the government. Yeah. So yeah, that's on that. Then a lot of answers I got was that the guy who did the IPv6 project left. Meaning that it was probably a one-man show. And yeah, we see that also a lot, that a lot of organizations have one enthusiast and is trying to run the show and bumps his head and bumps his head and bumps his head and then gives up and leaves. So that made me think, are a lot of these IPv6 deployment driven by a single person? Could be. Okay, so one of the main questions was, why did you disable it? Well, a lot of people said it was a test. The second one was restructuring network. That is also often heard, is that something else in the network was broken, so they switch off IPv6. Sounds familiar? Yeah. So that is basically restructuring network. You do something in the network and you switch off IPv6 and you have the best intentions to switch it on and you forget about it. That happens a lot. We had hardware issues. Well, we had the guys leaving. Another one was with the restructuring network. They switched it off and they didn't switch it back on, but they were also not monitoring it. So that's where I got a lot of the emails from the managers saying, oh, thought it was on. I even had one case where there was an ISP, which was interesting. They said, what do you mean? Our upstream is supposed to announce this for us. We pay for that. I was like, well, no. And then I looked in what's it called? RIS, our tool to check, basically it's stats.ripe.net, where you can check if a prefix is announced or not. And then by the end of the day, I see something strange. It's being announced. While I was emailing back and forward with that manager, I see it being announced. I thought, that's weird. And I said, well, it seems to be on now. He said, well, okay, I just called them. Maybe that has something to do with that. So probably somebody probably just, while on the phone, said, what do you mean? No, it's working, really. Try it. Click. And it worked. Yeah. Back on. Thank goodness. That was all good. So yeah, we heard also in the big member survey, the reason why not to do IPv6 is no interest from customers. This is one we hear in the training courses also all the time. there's no customer demand. And I don't think IP6 is a matter of customer demand. By now, it's 2016, it's mostly a matter of business continuity. If you want to be in business in 5, 10 years, you have to at some point. A lot of the guys were, like I said, just testing. The infrastructure changed. We changed something, didn't re-enable IPv6. Also mergers. So a lot of guys who had a merger that were using the IP6 before, then moved to a different network, different AS with a different IP6 prefix. We saw that. Then we got some interesting stuff. We were under huge DDoS attacks all the time. I thought, was that IPv6 DDoS? But probably, I don't know. Could be. Who could tell? Stress testing issues. The tunnel broker, yeah. Orla was mentioning 6-Access, and 6-Access is not accepting any new customers, so to say, because 6-Access thinks it's 2016, it's time to move away from tunnels, and basically more and more of the tunnel providers, tunnel server providers, are pulling the plug on that now, so we see that as well. And of course, they didn't realize that the announcement stopped, so they might want to monitor that. Monitor your IPv6 as well as your IPv4. Important lesson. I wanted to know if they also stopped IPv4. Yeah, while I was at it. Some of them said yes. And if you look at the next one, no, it was the previous one. I think it was this one. That's about the same as the bankruptcy. See that? So that could be that. And the rest didn't stop IPv4. Just checking. And then I asked, when do you go back on IPv6? A lot of them said, I don't know. Nobody said never. That was good. Was happy with that. But so this was about a year ago, and I checked last month. And from the 462 of them, we saw that close to 300 are back online now with IPv6. That's quite a substantial number. So a lot of the guys that said, I don't know, actually came back. Now I have to be honest with you. I saw some other drop off the table, of course. So it's, yeah, that's what happens. But I keep chasing them. I got a lot of emails saying, oops, sorry, fixed. Thanks for the reminder. Some guy said, okay, we had a merger, forgot about that whole prefix. You'll get it back. And some people said, well, we changed providers. This one doesn't do IPv6. So when they start doing that, we'll get back. Last question I asked them, how can we help? Is there anything I can do to help you get back with your IP6 announcement? And people said, yeah, we would like more training, addressing plan tips and tricks, best practices. So all these tips we are working on in some way. We have translated the ServNet document for IPv6 assignments for addressing plans. Points for best practices. We've got the BCOP task force in RIPE working on that. Provide more training. We do a training every week in a different country for IPv6, and they're full. But people want more and more. You can see that there's a big momentum for IP6 training at the moment, so that's good. I was afraid people would be offended by me asking, being so nosy, but they mostly weren't, so that was good. And that's it for me, basically. I was happy to see most of them, they do come back, and the rest I will chase. This is the RIPE Academy. Just a quick plug, because I'm also a trainer, so yeah. IPv6 training. You can also do that online with our online academy. Thank you very much for your attention. Do we have time for questions or not?
Yeah, we do 2 quick questions, and then we're going to have a quick break. Anyone got questions?
Yeah.
Go.
Megan, so you said it takes about 2.5 years to transition from V4 to V6. What do you see as the biggest hurdle for a company going from V4 to V6?
Would you mind repeating that?
Yeah. What is the biggest hurdle for an IPv6 deployment? From what I hear is that it mostly starts off with 1 or 2 people in the company who want to do this, and getting buy-in from the other departments is what I hear is quite a big struggle. Also, the uncertainty of what it will cost, so the cost factor. So I asked a lot of organizations, big ones, small ones, vendors, what does it cost to do an IPv6? Where does the money go? Not what does it cost, but where does the money go in an IPv6 deployment? And most of them, both on the content side as on the access side, same as Cloudflare, for example, they all have the same answer. It's man-hours for software engineering to fix scripts, provisioning tools, billing tools, stuff like that. Man-hours.
Thank you, Nathalie, once again.
Thank you.
Sure. So my name is Ed Horley. I'm actually the VP of Engineering for Groupware Technology, but probably more important for this group. I'm the co-chair for the California IPv6 Task Force, and I'm also on the North American IPv6 Task Force, and I get to present internationally on IPv6 on a pretty regular basis. I wrote a book on IPv6. I don't know if that matters or not. It's just persistence. But on the IPv6 side, I wanted to talk a little bit today about sort of IPv6 and some of the operating challenges that go on with IPv6, and probably more specifically dual stack, because that's probably a bigger issue for most people, because that's typically how most people are actually implementing IPv6 today. And if there are any specific questions around this, just go ahead and holler. I prefer to just answer them as they happen. I realize, across the pond like this, it might be a little bit more difficult, but feel free. I'm going to just go ahead and jump into my slides. I'm going to shrink this so that hopefully that gets out of the way on the screen. And I gave you folks the slides, so hopefully those will get redistributed out. They're nothing super exciting, but we'll jump into it. I wanted to talk about IPv6 adoption overall, and specifically from the operate. So out of the whole methodology that you all are familiar with design, deploy, operate, maintain, really want to focus today, at least on the operate portion, because there are plenty of folks that are actually talking about design and deploy quite a bit. I don't know a lot of folks that talk about maintain, but the operate side is sort of an interesting challenge that goes with IPv6, because it isn't a straight cutover, right? It isn't something where you just turn IPv4 off and have IPv6 up and you're just operating on that all the time. For most folks, it's actually a dual stack situation, and so I wanted to really cover those portions of it. So this is really a focus on the IPv6 side of the operations in a dual stack environment. So I wanted to outline what I thought some of the problems actually were for operators around IPv6 and what goes on with that in a dual stack environment. So let's talk about that really quickly. I think help desk and knock is one challenge or problem that people are going to have. You're going to have monitoring, application challenges, third-party services, some things around feature parity. And I don't know if you folks have talked in depth about feature parity versus functional parity and the differences between the two and what impact that will have, but I think that's important. Your overall knowledge, so the knowledge around IPv6 in general and how that might impact what's going on. Dual stack, and specifically what I mean around dual stack is understanding how different operating systems and how different network stacks actually implement dual stack versus maybe just one traditional IPv4 stack versus maybe an IPv6 stack. And then how each operating system actually handles the stacks differently, because there are different implementations across different operating systems. And then translation. Translation is a really big one, because in dual stack we have to use translation for those sort of service islands of IPv4 or IPv6 that live alone within our network, and translation is going to be an important aspect of what we do with all of that. And so from an operator level, if you have any problems with translation going on within your network, you're going to run into some very significant hurdles, right, in terms of understanding where your problem set actually exists. And I think for operators, for all of these, your problem and challenges really are around determining where the problem actually exists in a dual stack network. Is it in an IPv4 land, is it in an IPv6 land, or is it actually in the translation between the two? And then this is more of an aside, but I think the real problem for all of us, and I have to have some sort of turkey in here because it's Thanksgiving for us out here in the US, but the real problem is actually that IPv4 won't die. So, and this might sound a little strange, but actually all the problems that we have back here all principally actually are driven around the fact that we have poor knowledge about IPv6, and that the implementation that we do in dual stack bubbles up into all the other portions of what I list out here, which is application changes, the feature parity, monitoring, all the help desk and knock issues you're going to run into, translation itself, and the third-party services. We're stuck with IPv4, and I think we will be stuck with IPv4 for quite a long time. I don't see it actually tapering off substantially for certain portions of network for potentially a lifetime of that network. But the reality is that IPv6 becomes actually a much easier operator problem to solve once you're actually on v6 as a native service. And I don't know if everyone agrees with that, but for those few rare folks that have had the opportunity to actually work on an all-native IPv6 stack, it's actually a lot easier to figure out what's going on and what might potentially be going on wrong in your network as an operator than it is to actually be running dual stack. So I'll leave that as is, and we can argue through that one later. So, and to reemphasize, I think the operation issues are really exactly this. You got dual stack, and which one is actually the issue?
Sorry, once again, we just had a screen go down. Oh, 2 seconds. Okay, keep going.
Sure. So I think the issue really on the dual stack side is which one of the protocols is actually the issue, and it's very hard to actually figure this out. I don't know, sort of informal poll maybe to figure out how many folks are actually running dual stack already. I guess I could pop my video back up here and see if have an idea. How many folks are actually running dual stack right now? Just click raise a hands. Anyone actually running dual stack actively? So it looks like about a quarter of the room, maybe a little less. So out of that, how often are you actually spending the majority of your time troubleshooting on problems for dual stack? The majority of your time is actually trying to figure out which protocol is actually giving you the problem. Is it like 50% of the time you're actually trying to figure out which protocol is actually giving you a problem as you operate your network? Is that about right, or is it more? What's the feeling? 20% of the time? 0% of the time? You know instantly which protocol is actually giving you the problem? Dang, you guys are good. A lot better than I am. I would say I would spend on the networks that I operate, that I work with customers on that are dual stack, I probably spend close to 50 to 60% of the time actually working with them about which protocol is actually the problem at any given moment. And does anyone default back to the just turn IPv6 off to figure out what the problem is? How many folks do that one? Come on. I know everyone does that one. Where you go in and you say, oh, let's just turn off v6 really quickly and see if that's the problem. Does anyone actually take the strategy of turn off IPv4 to see if that was a problem?
So now we have IPv6 switched off for that reason. Yeah, in their previous.
So I think it's really funny because the majority of my customers, their first response is, let's turn off v6 and see if that makes the problem go away. And so my second question to them is, well, did you turn off v4 and see if the problem went away too? And the reason that they do this is because they have no idea operationally which protocol is actually the problem. And I think this is a really important point for those that are spending a lot of time on dual stack. And I'll flip off my video again so that you guys can see the screen. But I think this is a really important operational issue to capture and to start thinking critically about. I'm not saying I have solutions for all of this, but I am saying that for those of us that are doing operations and helping customers get through the operation side with v6, I think this is a really interesting thing to have a pretty open discussion around how you actually deal with this. Anyway, the next portion to sort of cover was just tactical, and I just want people to have these as handed out, and I apologize for just listing them all on a single screen. I guess I could have broken this up, but I think one of the biggest challenges we run into and things that you can tactically do to sort of address this from an operation standpoint is really, deal with the IPv6 education gap. That's a big one. So just spending continual time working on and educating on IPv6, because if you're going to run it and operate it, you really need to understand it in a much better way. I list out here focus on moving from functional parity to feature parity over time. Does everyone actually understand what I mean between the two of those, between functional parity and feature parity? Anyone, you guys want me to walk through that really quickly? Give a quick example? Would that be useful?
Yeah.
Okay, so functional parity would be something like I need to be able to ingest logs from IPv6 or a dual stack device. So I don't care, my router may be doing v6 just fine and able to provide v6 logging information, but maybe it's getting back to the logging service utilizing IPv4 as a network transport. You're getting functional parity. You're able to get v6 log information into your logging system, so that's functional parity. Feature parity would be that you're actually able to transport it over IPv6, so you have a one-to-one correlation. So v4 is able to send its v4 related logs over v4, v6 is able to send its v6 logs over v6. You have true feature parity. for that particular feature, which is a logging service feature on maybe a router, versus functional parity, which is I could still able to get my v4 and v6 logs, but it just has to be transported over v4. And so you're going to have a lot of services within your stack over time that are actually built out and probably have a lot of functional parity, but may not have feature parity. And what you want to do is transition from from functional parity to feature parity over time, so that way your network is able to operate in a v6 only environment without necessarily the dependency on the v4 resource. Hopefully that makes sense. Next ones would sort of, if possible, run IPv6 only to allow for skills with debugging and operating issues. And I think this is important to have a small portion of your network, if you're running dual stack, that actually is v6 only, that people can jump on, actually test stuff, and be able to debug what's going on. If you don't do that basic level, you actually don't know if something's operational in v6 only environment. And that's probably a big one that's missed by a lot of folks. On the help desk and NOC side, this one's really, this one's a little strange because most of the folks that actually are network operators that I work with don't spend a lot of time on operating systems. And so they actually don't know how RFC 6555 is actually implemented in most of the major operating systems. So they don't know the difference between how it's implemented in OS 10, how it's implemented in Linux, how it's implemented in, Windows. So they have a really challenge in terms of understanding what core, host devices that are actually connected to the network are actually doing at any given moment. And they also don't know which devices are actually RFC 3484 versus RFC 6724 compliant, and at what time frame they would have switched from one to the other. And so I think that's, and apologize, RFC 6555 is the happy eyeballs RFC. So for those that are running dual stack and want something that fails back and forth quickly between v4 and v6, that's RFC 6555, which is happy eyeballs. And it has different implementations in every operating system. So your help desk and your NOC actually needs to understand how that actually works, and then in pretty good detail, some sort of flow chart to be able to get through to understand out of the supported network devices on your guys' network, what those behaviors actually are. And that really helps reduce that whole mystery network problem of like, well, it worked here, but then it went over here, and then it disappeared, and I'm not going to worry about it anymore. And so we're just going to close that help desk ticket, which is how we all do it, right? That's not a problem anymore. We'll just make it go away. You really want to understand what's going on the network, and that's something that's really useful. RFC 6724 is something that your general help desk team definitely needs to know also, which is actually the flow for the prefix policy table inside the operating system. So every major OS makes use of RFC 6724. The older version of that was 3484, and so you need to know the difference between the two and when you switch from one to the other, because it actually changes the routing behavior of your operating system, which is a little strange because that's another net new concept for v6 is the fact that your host operating system gets to make routing decisions. How many folks are comfortable with that? Run a network? Everyone comfortable with your host making routing decisions for you? Okay. I'm totally cool with it, but how about the rest of you? Run a network? Yeah. So that's a new thing, and you probably want to take some pretty specific guidelines in your design to sort of work around that problem if you see it as an issue. I don't know if the rest of these are really worth going through, but they're a good checklist to sort of flip through. I think one that's really interesting is the monitoring one, and that actually gets to this next sort of slide here, which I think is might be a little bit more fun, which is sort of the story time side. How many folks actually have active monitoring for v4 and v6 and actually know the difference between the two? So a lot of you, fair number. So this is it. I'll share a little bit of a story because I was active with a customer doing some cutover and actually helping them turn up some v6 on their network, and taking the regular sort of outage windows to be able to turn up services, and they had not done the right thing in terms of their monitoring service in advance. And so when we actually did the turn up for a significant portion of their client-side VLAN networks to actually get their client host operating systems switched over v6 enabled, they all flipped over and started sending their traffic via v6, right? So everyone understands the majority of the time, right? v6 is preferred for almost every major operating system. So it's going to flip over, prefer v6, you're off to the races, and off you go. They made the mistake that they were actually doing most of their monitoring as L2 port interfaces, and so that looked great. There was no problem. They were still seeing the same amount of overall traffic. but they had forgotten to actually add the L3 interface for the V6 into the reporting system for monitoring. And so all they saw was a nice graph that had like their traffic drop from like, you know, the current steady state, whatever it was, you know, about 40% of utilization of the port. And it just dived off and was below 5%. And they're like, oh my gosh, there's no more traffic actually happening. We broke the network. I'm like, did you actually add the V6 interface, logical layer 3 V6 interface? Because all the traffic flipped over to that. And as soon as they got that added back in on the monitoring side, like everything looked normal again. But for a good 30 minutes, everyone was running around acting like the entire network had crashed when everything was operating just fine. So I think there's a story to be learned there about just understanding the technical differences between V4 and V6 in terms of what interfaces you're actually watching, what's important to you. Having graphs that actually display that information correctly for you is going to be really important, and you want to play with that before you actually roll into production. And so for your operators to actually understand when they're running into a problem and when your traffic's actually flipping back and forth. That's the other interesting one is the selections of routing protocols and fate sharing that you choose will actually change some of that behavior. If you're ISIS shop, right, you're going to have shared fate based off links. If you're doing OSPF, you're going to run 2 Dijkstra algorithms, and 2 different routing paths may be selected depending on what's going on internally and how you tune your network. So those are things that are going to be really important considerations just for you overall, and will impact how your operators, in other words, how your NOC is actually viewing your network at any given moment. And you need to be able to display the difference between the two. And if you have dependencies between the two, you need to be able to display that dependency information. So as an operator, you need to know, is my BGP and my requirement for BGP for V6 actually reliant on my BGP peer links for V4? And if it is, I should be able to put some sort of piece of information in there that tells my network operators, hey, if my IPv4 BGP goes down, my IPv6 BGP is going to go down, or vice versa. And hopefully you're running them as ship in the night and they're not related to each other at all, which is probably best practices. But even though you may be sharing the same physical, you know, layer one link for it, I think it's still important to operate them separately. So I think those are interesting things just from an operator perspective about design decisions and what they will do to you long term in terms of operating your network. With that, I'm going to shut up for a little bit and see if there's any questions.
So, hey, Ed, I've got a quick question. One of the questions earlier were around tools for management, around address management, and some people are doing interesting things. So you mentioned monitoring. What are you seeing out there in terms of, I guess, IPv6 readiness from the monitoring tools and also asset management and address management tools?
Well, on the commercial product side, you know, obviously, full disclosure, I'm on the IPv6 Center of Excellence for Infoblox. So Infoblox obviously has support on the V6 side and has done a pretty good job over time with that. But obviously Bind does a great job on the DNS side. There's lots of other tool sets that are available that do a good job with V4 and V6. So if you're a simple SolarWinds shop or you know, a variety of other tools, so if you're using BT Diamond or something else, you're going to be fine on terms of V6 support and what's available. I think the bigger challenge is going to be really having correlation information in monitoring. I think that problem has not been solved by most of the major manufacturers. So if you have an IPv4 host and an IPv6 host, are they the same device? Are they different devices? How do you stitch the address correlation information together? And if you're security-minded, how do you actually get event triggers that are maybe coming from the V4 side doing something correlated with maybe bad behavior on the V6 side, and is that the same host or not that's operating inside your network? And I think that problem really hasn't been solved particularly well. So that's probably the biggest challenge I've seen out of the monitoring tools today, is that the correlation information is really, really poor in terms of making that automated and easy to use. For commercial enterprises, I have not seen anything that's particularly a standout that I would recommend over having to cobble something together yourself to build that. I don't know if everyone else in the room agrees or disagrees. Any suggestions on other products they've seen or had really good results with? Because I would love to hear if someone's had a great experience with the tool.
I guess point of information, because I don't think I answered this question very clearly earlier. We tend to use a lot of open source tools. So for our monitoring, we use HEAnet or Nagios or Netscape, whichever type we came to it, and that supports IPv4 and IPv6. So we make sure that every host has both V4 and V6 within the template for the check. So we do everything within the one check so that you can see straight away it has both. Operationally, we found it very useful to just tag on to the host name -v4 and -v6, so you can straight away see that the problem is v4 or v6 related if it's a particular end host, be that a router or a server or whatever, and that's helped immensely with it. But one thing I just wanted to say as well with the report there was one of the biggest mistakes that was made initially with IPv6 deployment was people didn't realize their IPv6 BGP sessions were happening over IPv4 BGP transport. And that really caused a lot of confusion operationally and troubleshooting problems. So for us, we explicitly say no IPv6 on the v4 sessions and no v4 on the IPv6 sessions. And that's, I guess, something that we learned the hard way that I think is a really useful thing to do. But it rules out any possibilities for error on it.
Yeah, I couldn't agree more. That's caused huge problems for me with customers when they were first doing v6 turnups, especially around BGP. I just like to keep them separate. It makes things much easier operation-wise.
Anyone else? So keep going. We've got one more question. Ed?
Just the relationship to what I asked. In terms of configuration management, let's say with ACNs or firewall rules, is there any tools that would keep consistency between, let's say, security policies that IPv4 versus IPv6? Is there anything that...
So Ed, do you want me to repeat that? Can you hear?
I think I caught it. In terms of getting policy configuration consistent for ACLs and for firewalls between v4 and v6, was that the general gist of it?
Yeah.
Yeah. So this is the point where I get to disappoint you with tiers. I would say the majority of success that I've actually had in that area is to actually use, it's a switch to being much more of the sort of network automation side and looking at, Ansible and Python and using that as a tool set to be able to make things consistent. I would say that there are a lot of times when actually v6 is the opportunity to start fresh and not necessarily repeat all the mistakes you made with v4, especially around your firewall ruling sets. Normally, when you're transitioning over and turning v6 services up, you're going to have discrete sets of services you want to provide. And I would actually take the opportunity to narrow down your list set and actually just turn up the specific v6 ACLs that you actually require. If you have backbone policy enforcement or route redistribution rules, I would definitely get that into something more like, Ansible and Python and push that out that way. That's going to allow you to keep things consistent because you can do consistency checks for testing and runtime versus just pushing something out there and hoping that everyone actually got the match between the v4 and v6. And then you can also put comments in there to map them together. Out of curiosity, for those that are operating dual stack networks, how many of you are actually embedding any v4 information inside your v6 for shared network address space? So you actually got, VLAN 10 that's operating for v4 and you've turned it up for v4 and v6. Are you actually embedding any source of v4 information inside your v6 to make it so that you actually know the two of those are actually correlated together as networks, or do you just treat that as entirely separate and don't do any embedded information at all?
I think most people are shaking their heads. They don't.
We do.
Oh, sorry.
Yeah,
and I like to. The reason I ask this is because obviously I don't bother doing this for RFC 1918 space. For public v4 space, I absolutely do this, and I'm sort of curious about why other people would choose not to include some of that information, just out of curiosity.
So I have a bit of an obviously knack for remembering IPv6 addresses, but nobody else in the HEAnet has probably just been working with it for so long. So one of the things we do is on the services side, we embed the VLAN that the addresses belong to into the IPv6 address. So obviously that does burn some address space if you don't have the VLAN A or whatever. But it's a nice way to logically map the address space to a functionality. And we put that in one of the bits and the exit, and then I can read an IPv6 address and tell you that belongs to that data center and it's on that VLAN. And that's a huge starting point to troubleshooting to be able to do that. And like thereafter, we have also for particularly public IP addresses like our main service or our FTP service embedded the IPv4, converted the IPv4 address into hex. And so 193.1 is HEAnet IPv4 address space. And I know straight off the top of my head that's B101 in hex. So if I see that anywhere, I know that tends to be the conversion of an IPv4 address into an IPv6 Yes, and it becomes second nature very quickly if you have those kind of monitors to remember, in my experience.
Yeah, and I've done similar schemas. Some people choose to convert it into hex. Some people leave it as decimal, which I find interesting. It's a little strange to read it that way because it actually doesn't translate one for one, and I prefer actually converting it because, you know, it definitely, I don't need to, well, I guess some people argue human readable is actually more useful because the machines can convert it automatically for you. So I guess it depends on your use case and how you want to do it. Anyone else have preferences on that?
So Ed, I'm just going to give you maybe like a 3-4 minute morning mark, if that's okay.
Sure. Yeah, absolutely.
So maybe we keep going, or
well, that's pretty much it for me. So it was just Q&A from here. So I just wanted to.
Too easy. So anyone else? Anyone else in the room got any other schemes for embedding information in V6 or any of the large rewards?
How many folks have completely abandoned their V4 design and said V6 is my opportunity to sort of jump in the bandwagon and move on, and I don't have to have all the constraints? Yeah, that's very cool. That's a rare opportunity. I challenge everyone in the room. This is a rare opportunity as someone who's, you know, in networking. How often do you actually get to go through and really think about how your build of your network's really going to work, and the chance to sort of redesign it from the ground up without necessarily having to redesign the physical infrastructure, redesign your network and addressing plan, and having that much address space available to you to not have sort of natural constraints? Because I mean, there's some crazy math you can do. I have some articles maybe I can throw over and share, but if you think about just small things like moving to containers and moving to microservice architectures, and even in a single /64, you know, I don't know, whatever, 10 million containers a second you spawn, right? And it's going to take you 58,000 plus years to burn through all your address space doing that, 10 million a second, all right? And we're not going to have the data center you're operating today isn't going to be around in 1,000 years, never mind 58,000 years. So it really opens up the capabilities of what you might be able to do. It also means that you can treat addresses as completely disposable, you know, disposable items per flow, which is something we were never able to do with V4. So if you have a flow happening from one end to the other, you just use the address for once, and if the container goes away, you never reuse that address again. Think about that. That's sort of wild, right? So I think we could open up some possibilities about what we could do with V6 that maybe we never thought about before, especially around IoT, containers, and microservice architectures. I think that becomes a really interesting, and mobile too, a really interesting area that we never really have thought about or discussed in any great detail, which is sort of a bit of a tangent from the operator side, but maybe on the operator side that becomes the challenge of how in the world do you track all that stuff. I would say V6 gives you a better opportunity to track things uniquely, one-to-one, instead of having to keep all that NAT table information in every stage of translation that happens throughout your network. So at the load balancer, at the firewall, at the, you know, going through whatever NAT translation devices happen internally and then get to a specific service. You're having to track that and log that information the entire way. What if you just had a native service coming through once? You just have to track and manage the policy itself, and you're just tracking one flow, one piece of data set information. Just think about how much storage space you save for reduction in logging. So there's some interesting things that actually are structural advantage for V6. And I would recommend actually trying to get Paul Saab on to talk about the V6 only data centers work he's doing at Facebook. I don't know if everyone is aware of that, but Facebook has an entire V6 only data center, and talking about the challenges and actually providing V4 as a service that traverses across their V6, provides that to the specific host that requires V4, and then recovers that back when they don't need it anymore. It's a pretty neat architecture. It's something definitely worth talking about. So for those that might have the opportunity on the V6 only side, it's pretty cool.
I was going to say just one other thing that I don't know how well it will scale because we have about 65 customers, so it works very well for us. But you can use the IPv6 address space to embed your customer information, so like assign a customer ID and use one of the 4-bit hex digits to track your customers that way. So you can look at a portion of the address and go, well, that's Trinity or that's CPU. And it again helps with the troubleshooting element of it that builds it up in the yard.
Okay.
Yeah, absolutely.
Yeah. So we've got one more question. We're going to wrap up on it, I think.
Okay.
And just before we do that question, well, yeah, let's do it. So go for it. Sorry. Yeah.
We do use. Do you want to come a little bit closer?
Do you want to come a little bit closer, or I can repeat? Let's see.
We do use some. We do encode some basic information in our purposes, like I don't know, data center IDs or clusters. But we also found that there is a problem that there are diminishing returns also on too much information on this because you rely on automation or directory services to basically retrieve where the location is. You abstract yourself from that, right? I think we tend to add this human component, or we try to attach to this human to try to understand the addresses sometimes because of what we used to do. So now we try to replicate that in addresses. I think there is value sometimes, but sometimes it just makes it a bit more complicated. So there is a balance there.
Did you catch that, Ed?
Unfortunately, I didn't. It's just a little too faint for me to catch that.
Okay, no worries. I can try to paraphrase. Miguel from Facebook was just mentioning that there's a diminishing marginal return for the more and more information that you try and code into the V6 address in a way to try and abstract it and make it more usable. That it actually, yeah, there's a tipping point. So
yeah, I would agree with that. I would actually say that some of the structural advantage you get out of V6 is the fact that you've got so many addresses to actually burn through and dispose of that if you embed too much information, it becomes a bigger burden to actually manage that than it is just to consume the address itself. Especially when you get down to microservices architectures and very small-lived resources that you might assign V6 addresses for a short duration of time and just destroy or get rid of after that. So I would agree with that. I think overall, from an architecture standpoint, too, is you have to sit there and figure out what structurally makes the most sense for your organization and how you operate. So for someone like Facebook, it definitely makes sense to maybe think in an entirely different way about how you want to use the abstraction that V6 provides versus if you're a manufacturer or if you're someone else who's maybe doing something different, maybe has a smaller footprint than what they're doing and doesn't necessarily have the hyper expansive sort of scale growth problems that someone like Facebook is going to run into. For those of us that are maybe running on a more traditional enterprise network, you're going to have a set of problems that you want to solve, and I think maybe embedding information does help you solve those problems. I've dealt with a very large manufacturer of big yellow equipment that's based out of the middle of the United States. I think that's close enough. And part of their challenge was how many sensors they were actually going to deploy on their equipment that was actually sold and distributed to customers out in the field that are working on very large construction projects, and how do you data gather that sort of information? And is it useful to have embedded pieces of information to actually indicate what systems are operating on it? And does that give too much information away? And the trade-off really is what utility is useful and how are those devices going to be used? And I think that's a trade-off that you have to sort of sit down and figure out where the business value actually lies. Is that useful? Is that fair?
Yeah. One comment on the microservices that you mentioned. One initiative that we are driving quite a month actually on Facebook is we run containers all over the place, as you can imagine. Our own solution. We presented actually in the ITF draft about ILA, identification, locator addressing. And at this point, as I speak right now, we have every server in the fleet deployed with /64 prefix per host. So we basically allocate a /64 prefix for every single host in the data center. So we aim at some point to have one IPv6 address per SAS instead of per host, right? So instead of multiplexing ports over the same IP, we will have dedication for every task will have a dedicated IP. So there is a bunch of code that you need to read to avoid port collision and port allocation. So we wouldn't have to deal with this. And this is something that with V4 we wouldn't be able to.
Right, and I actually wanted, I've been considering or scratching my head about submitting one that would actually allow host operating systems to think much more service provider basis, especially for someone of your guys' size, to maybe consider something like using DHCP v6 PD and having the host be able to request based off of policy enforcement, hey, I need an additional /64 to be able to do isolation for a particular container need requirement. So you can ask for as many /64s as you require, depending on how your container orchestration platform is actually distributing resource requirements. So whether Kubernetes does this or Mesos does this, or well, Docker's in its own little mess with Live Network. But I think we could come up with an architecture that actually is pretty unique in terms of saying, hey, if I have a service need and I want to be able to do service chaining with OPNFV or something else of that nature, you could do some very interesting things with V6 to solve those problems. And if for those of you that are following the OPNFV side, one of the things you want to check out is in-band OAM that Frank Brockner's from Cisco has actually submitted in. Really interesting capability to basically be able to take a signed portion of a V6 address and embed that in as an extension header to prove that the packet flow actually went through that device. So if you have a service insertion configuration that you want to do, and you need to ensure that that particular packet flow went through a particular firewall and then through a particular load balancer and then through a particular web proxy service or whatever, in-band OEM would actually sign it at each point and then check that in as an extension header in V6. And so you could actually validate path flow at the end of the process to confirm that it actually took the path that you dictated you wanted it to take as part of your NFV process. So I think those are some interesting things that are actually happening in the industry overall that just aren't even possible in V4 today. So, but I agree on the microservices side. It's pretty impressive what you can do with the amount of address space that you're given. To be able to do that on a per host basis and not have to worry about the port collisions and all the remappings that have to happen, nor do you have to log any of that information anymore, which is really cool.
So Ed, I think we're going to wrap it up there. I'd just like to say that Ed has joined us on his Thanksgiving day from home. It's actually his day off. So thank you very much indeed, Ed. Really appreciate it. And thanks to SIG. This has been a great experiment. We might be getting a couple more presenters in. But maybe just give a round of applause for Ed.
Thanks so much, everyone. Really appreciate it. Appreciate the invite.
Really appreciate it, Ed. We're going to love you and leave you, and we'll have a beer with you the next time. Hopefully you're in Europe. So.
Yeah, someone shipped me beer. What happened there?
Thank you so much indeed.
All right. Take care, everyone.
Okay. Bye-bye.